Okay, today we're going to be doing a little basic JavaScript, some survival JavaScript. Just going to be covering basic principles today. So enough to look at some of the code, understand what's going on, and we'll be playing in NodeJS environment on VSCode so you can get a feel for how some of this works. So JavaScript, and probably we should cover this right at the top, the proper name is ECMAscript. ECMA coming from the acronym for European Computer Manufacturers Association. And when we talk about ECMAscript or JavaScript, it depends greatly upon the version. It's been around for many years, as you probably know. The kind of modern JavaScript is ES6, also called ECMAscript 2015. And the version numbers have been pretty much keeping with the version number plus 9 equals the year. So ES10, the 10th edition of ECMAscript is ECMAscript 2019. We're going to focus on ES6 as the change from ES5 to ES6 was pretty huge, and it added an awful lot of basic fundamental capability. And introduced classes, modules, iterators, maps, sets, and promises, which end up being quite important for responsive web apps. So for why ES6 and why not ES10? Well, it has to do mostly with browser compatibility. So most of the current browsers handle ES6 without any problem. So we're going to use that one. And the difference between ES6 and ES10 is pretty subtle at this point. You don't get a lot of killer features that you can't do in ES6. So that's why we're sticking with ES6. So when it comes to learning, and I'm just going to use JS for short, JS, we'll start with some basic data types. Now I'm assuming everyone's had some exposure to programming, as this is a master's level class. So the basic data types in JS are a number, which in this case they don't really distinguish between integer, floating, and double. Everything's just a number. The usual string, so hello world in quotes. You'll find too that JavaScript is okay with double quotes or single quotes. I think the JS standard is single quote. There's a Boolean type, obviously true or false. And then an array type, which is indicated by a square bracket, and then a comma delimited list. And there's no requirement that those items are of the same type. So you can see in the example here, we mixed numbers and floating point and text all together. So in addition to some of those basic data types, there are functions. So a function is, as you expect, it may or may not require an argument, and it may or may not return a value. So I put an example here, get book author, War and Peace. So that's taking an argument of a string called War and Peace, and the assumption is it would return an author string or an author object. And then objects in JavaScript, they're denoted with a curly brace. So if you were to instantiate an object and set it equal to curly brace, it's basically an empty object. And the way JavaScript objects work is they hold on to a collection, name value collection, and you can extend it in real time, and you can query it, the named value, using either a dot operator or a bracket operator. And under the covers, that collection is maintained as a hash table. So for those computer science folks, you can use the underlying storage of its member name value pairs as its own built-in hash table. Although the size of that hash table has been optimized to be small, so it's not very good for storing, over 100,000 objects. In addition to the object and the basic functions and data types, there are also built-in global objects, and those have continued to extend as the different ECMAscript versions have evolved. Hence the ES6, added maps and sets and promises. So those were added as well. All right. So with respect to survival JavaScript, we're going to do enough to read basic JS code. We'll code together an example that covers most of the basics. We'll cover more complex issues of promises later because those can be really confusing, especially before you've gotten your head wrapped around a lot of the functions and callbacks and arrow function operators. So we're going to code together in class a class that'll do statistics on an array. And we'll start out with an empty calculator object in calculator.js and debug using Node and VSCode. Okay, we've opened our VSCode to a fresh new window. In this case, I'm working under the sample.js folder. The first thing I wanted to point out is we're going to need to get to our terminal. So we're going to go terminal, new terminal. And just so everyone knows, you have options between PowerShell, command, Node. You can set those up with some of your settings. Right now, I've just got it for a simple command window. And we're going to start off by making sure that we have our environment installed. Now, we would have done this in a previous class, but just to remind everyone, we can go node -- version, confirm that we have access to Node. We can do HTTP -server and do the same thing. Make sure that's installed globally. So we're looking in good shape there. Can clear our screen. And then when we're looking at files in an open folder, we do want to create a new project, npm project here to facilitate debugging. So we're going to do an npm init call. And that's going to create our package JSON file, and it'll do it through a prompt response. Now, just to keep things simple, I'm just going to keep hitting enter and accept all the defaults. You can decide to do it a little differently if you'd like. And you'll see when we're all done, we're left with a package JSON file that it created for us based on that prompt and response. And here are all those defaults. This is necessary for us when we configure debugging. So that's why we did that. So we're going to go ahead and clear the screen here. And then we're going to create a new file. And since this is looking like it wants index.js as our default file, we'll go ahead and do that. So we'll do an index.js. And so when we go to debug, which is this icon down here, it'll say, to customize run debug, create a launch JSON here. So we're going to go ahead and do that. We'll click on launch JSON. We're going to do a node.js. And you can see it defaults by doing a node launch. And it defaults to our index.js. And so let's, we don't have to add a configuration. I think that's pretty much all to go. Unless you want to name it, you might find that launch program might be less helpful than perhaps like run index.js. So we'll go ahead and name that, and we'll save that. And so now you can see on our run configuration is up here, we have run index.js. We have an index.js file. So when it comes time to debug, all we'll have to do is hit this run arrow and we should be running our index.js. So let's go ahead and start running a little, or writing a little code in there. As you can probably seen almost everything, just to confirm everything's working, we can do a console log, and then we'll just say it's working. And then we should be able to, probably gonna go ahead and put auto save on for now, so we don't have to keep doing that. And we'll go ahead and run that. And you can see it tells us some information right here. It's listening on this WebSocket for debugger, and we got this console log that it's working, and that comes out in our debug console. Okay, so when everything's working, so we're going to go ahead and start coding. All right, so let's start off with this notion of an object because we're going to build upon it. There's quite a few ways to declare an object. When you want one in the global scope, and the one you'll see the most often is just var. And so we're going to call this globally scoped variable calculator. And we're going to just set it, we're going to make it an object. And we're going to, by setting it equal to the curly braces, it's now equal to an empty object. That object it exists, it just doesn't have any properties. If we want to add properties to it, we can do things like, let's just say the calculator. This is going to be working on an array of numbers. So we're going to say that the data is an array. And we can tell it's going to tell it to expect an array by setting that equal to an empty array. Next, we'll set the average. We'll add a property called average. And let's see, to speed things up, I'm just going to put this in my paste buffer. So we'll say average, and we'll initialize that to 0.0. And we'll do the same thing for min. We'll say min is 0.0. And max. And to save some time, I'm going to go ahead and populate a bunch of these for you right from a paste buffer. So count, which will be the number of items in our data array, is 0. Date, we're just using that to, as part of a learning experience here, we're going to set that equal to the date when we do our calculation. And I should probably mention, we can probably start off with just some comments here. And it's a normal comment mechanism. So it would be calculator will determine statistics for an array of numbers. And we can, the last thing we'll probably do is just add the function that's going to do the work. And again, this is, I should point out these things, right? So everything after the dot is the name of a property on that object, and the object being calculator. So thus far we've had, most of our things have been numbers. If they're objects, we can set them equal to null, basically saying we haven't set them yet. That's a way for us to know that we will set them at some point in the future. But if we do check that property, the property will exist. We can check the value as being null to say, oh, we haven't initialized it yet, so we need to do something. And so the other property we're going to add is do statistics. And actually the right is do statistics. So we're setting that equal to a function. And we basically say, what does the function take? We're going to say an array of numbers. And then we put some curly braces saying what it's going to do is inside these curly braces. So this is where we're going to do our work. And then you can return something or nothing. An interesting pattern, which you'll see a lot, is return this. So sometimes, even if you don't necessarily need to return anything, you'll often see them returning to this point. And what that means is it's going to return the calculator object. And why that's useful is it lets you daisy chain your calls. So for example, if you do a bunch of things on this class, if you return the class, you can then say something like, and I'll just put it here parenthetically, you could do things like calculator, do statistics, you could pass in some data, which would be, an array, so we'll just one item. But then you can hit the dot operator, and now you can call average or min or max or whatever you need to do. So you can daisy chain these together. So that's where that becomes helpful. So I'll just comment that out for now. Okay, one of the things I like to do just so we can continue to debug stuff and make sure everything compiles and runs, is use the console log command, which you can pass in an object. So in this case, we're going to be passing in the calculator object. I should point out, I might mistakenly refer to this as a class. It's an object. It's a JavaScript object. There's a difference between a JavaScript object and a JavaScript class in particular. They behave very much like a class, but semantically, this is just a JavaScript object. When we call console.log on an object, it will convert this to a string representation of itself, and you can see it in the log. So if we run this, it should basically do a dump of the raw data of the calculator. And so we can see if I hit start debugging, debug console runs, and we see we have this object, and it talks about the data as an array, average is 0, min 0, max 0, count 0, etc. Okay, so we know that's running. The debugger is completed, so we can use this to clear the console. And we're going to start expanding on this. So one of the things that we might want to do to help us debug stuff is to create another method, a toString method, so that we can have some control over the formatting of the calculator. So let's go ahead and do that. So we'll do a calculator .toString method. Again, we'll set that equal to a function. Now this function doesn't need any arguments. And we're going to return a string. Now one of the things we're going to use is this nice way of outputting a string. And one of the ways I'd like to do that is to do it by starting with a local variable. So in this case, our local variable, we're not going to use the word var because that will make the variable global in scope. We want it to be just to our toString. So we're going to say let, and we're just going to call our output string. And we're going to set that equal to, not an empty quote. Now it's going to look really similar to a single quote, but it's not. This is the character on the English keyboard on the top left under the tilde. It's that backtick. I've got to figure out what the exact name of that is. But again, it's to the left of the 1 under the tilde. And that is a special formatting string. It has a lot of capabilities, one of which is you can format carriage returns and spacing within the string itself. So for example, I can do that. I can leave some lines in there if I want. I can do, for example, we'll just call this, let me just call this what we're hoping it to do, which is like array statistics. And then let's do in the next line, let's simply say the easy ones, because they're always defined, right? The min is going to start at 0, so we'll just say min equals, and this is where the backticks help. We can use the $sign and then curly braces, and you'll see that the color automatically changed. We can put a variable in there. So we can do calculator dot min. Now, of course, that's using this object. We could also just say this, which is the calling class. So we'll just do the min for now, and we'll call it a day with a min. Notice I'm not using any carriage returns, not carriage returns. We're not using any semicolons. You'll see semicolons used after lines often. They're not required under JavaScript and under the JS standard. They're discouraged except when needed. So if you're wondering why they're not there, that's why. It's not wrong. It's just a style preference. All right. So when we're done establishing this string, we're just going to return that string. So we're going to return the output string. All right. So let's go ahead and run that. And we see some errors. Unexpected template string. And of course, what happened here is I forgot my equal sign. It's obvious when you look at the squiggles that there's something wrong here. So I'm going to go ahead and put my equal sign there. That should take care of the problem. And let's go ahead and clear that screen out, and we'll try running it again. Oh, let's call toString. There we go. And you can see this lets you do some nice formatting because it allows the carriage return and all that sort of stuff. So it's pretty slick in that respect. Okay, so now we're going to start extending the function of this code. So the first thing we're going to want to do is start filling in this do statistic. So again, remember we're bringing in an array of numbers, and we're going to do calculate the min, max, count, all that sort of stuff. All right, so the first thing we should probably do is to check to make sure that whatever's passed in is the right thing. So remember, this can be anything. This could be a null, it could be another object, it could be a number, it could be an array of numbers, it could have numbers with strings in them, so we need to do some checking first. So the first thing we're going to do is make sure that it's an array. So if it, make sure it's not null. So we use the triple equals here to make sure that this array of numbers is specifically not null. And if it is, we will throw a new error object. So this again is a global object error, and it just takes a message you can pass in. So if we wanted to test that, we could do something like, we're going to execute some code here. We'll say calculator, do statistics, and null. And so we'll see what that ends up doing. So let's run that. And you can see it throws this error. So it says error cannot perform statistics if data is null. And it tells exactly where that happened. So it happened in line 14. So we could debug our code. Now we can leave it as is here. Or if we wanted to, we could capture that. So we'll just go ahead and show a capture this. So we're going to use what they call a try catch block. And so the way this works is anything that happens in the try catch block will try to function normally. If it fails and throws an error object, that error object will be caught here, and we can log that out. So for example, we could take this as a test. So it might say test handling a null pass to our method. So we expect that to fail. So we'll say something to the effect of console.log. We'll just put out the error here, and it should continue with the rest of these calls. So we should get to the calculator toString. Now, if you notice here in the debug console, we never got past the error. It terminated the program as soon as the error happened. So this shouldn't terminate the program. It should call do statistics with a null. That should throw an error. It should be caught here. And we should pass it onto the string here and continue on to log the calculator. So let's see how that works when we run. We'll clear the screen, run that. And you can see, hey, there we got error cannot perform statistics if data is null, and then we continue operating as normal. Okay. And one of the things we can do too, by the way, is we can use the debugger. So let's go ahead and use the integrated debugger. We're going to run this again. And this time we hit this breakpoint. And so we can use these debugging options up here, the continue, the step over, the step into, or step out of. or restart or stop. So in this case, if we want to see what's going on inside do statistics, we can do a step into. So we're going to hit the step into, and you can see now we're inside our do statistics call. And the neat part here is you can mouse over your objects and see what their values are. We can go and put a breakpoint in our catch block here. Just by clicking over here to the left of the 30, you can toggle that breakpoint on and off. So we're now going to single step. It's going to throw an error. And then here's that object that we've got. And here we can mouse over our error object and see what it is. You can see it has a message, which we passed along. Actually has a stack object, which is pretty interesting. We'll talk about more of that later. So what's being passed is the entire error object. And we can learn more about the stack by calling a method on that later. Okay. And then we continue on. All right. Let's go ahead and stop. Now let's start filling in our functionality. So we've made sure that the array of numbers is not null. But we also need to make sure that it's at least an array of some length. So make sure, and also make sure it's numbers. So let's just copy that. Let's make a new method, and let's call it, we need to check to see if it's an array. So we can call a built-in class called array. We can say is array, so that comes for free from JavaScript. And we'll just say as long as it's an array, actually as long as if it's not an array, so we use this exclamation point to reverse the logic. So this is saying if it's not an array, then we'll say cannot perform statistics if data is not an array. How's that? All right, so we've confirmed that it's not null. We've confirmed that it's an array. Now we need to make sure that there's no numbers in there. I mean, excuse me, nothing but numbers in there. So we need a method to check that. Now, there may be something built in, but just for the purpose of this, we're gonna have a method. We need to make sure that it's a finite numerical array. So we'll just say we want a method that'll say like is finite numerical array. And we'll say cannot perform statistics if data is not an array of numbers. Okay, so we need a function that'll perform that for us. So, and we can put it up here if we want. So we'll just call this, so we'll put it after the main comment. We'll just call this helper functions, because we may want to use them outside of the calculator class. So if we just want a global scope function, we can just declare it. We can basically say, oh, now we could use var, we could use let, but the most appropriate is yet a third way, which is const. And this is a var which is constant, which is to say, since it's a function, it doesn't change anything. So if we had, it tells the compiler to treat this a little differently for checking, or interpreter for checking. So we're just going to say this is a function, is finite numerical array, and we're going to pass in our data. We'll call it array of numbers, hopefully. Can we put our curly braces there? And so what we're going to want to do is we're going to, actually let's make that more appropriate. We're going to make this a more generic function. We're basically going to pass in object to test. And we're going to test that null check that we're already doing, right? So, and we'll just return false. So rather than throwing an error, we'll just say, if object to test is equal to null, we can return false. I forgot to do this. So this is equals function object to test. So again, we've declared our variable is finite numerical array as a function. We've said const because it's not going to change the state of anything. And we're going to return false if this was a null. Then we're going to do the same check we did before, right, which was an array. So we'll do something like, if it's not an array, we'll return false. So here's our array check. We'll return false here. Now we need to, we know we've got an array. We should probably just make sure there's some elements in there. So let's make sure that if array, actually we know this is an array already, so you can just say object to test. Length will tell us what the number of items in there is, and if it's less than or equal to 0, which is probably redundant, by the way, can't be less than 0. I don't think length will ever return less than 0, but we'll just leave that in there and return false. Okay, so now the last thing we need to check is to make sure that everything in there is a number. So this is going to let us test the iterator. So there's built-in iterators in ES6. We can see one here is for each. And for each, what that does is, I'm going to just type element here. So you can type whatever you want, and it doesn't matter what it is. Basically what's going to happen is for each is going to go through every item in object to test, set it to this value that we're calling whatever we want, in this case element. And what I can do is I'm going to do what they call an arrow operator. And this says inside this for each, I'm going to have an element that I can use. And I should actually, let me just draw it this way because it's a little bit more obvious to see. If I delete some of this stuff and make it clear that, and this shouldn't be here. So this is the line. For each object to test, it's going to pass the value into the element, and then it's going to call through this arrow operator the code that's inside here. So I'm going to put a carriage return inside here to give us some space to write. Now what I can do here is I can basically use the built-in object number. I can say if not number is finite, and I can pass in the element. I can return false. So if any one of these elements is not finite, return false. And I've clearly lost my end bracket, so we'll have to put an end bracket in there. And so if we've passed everything there and nothing's, we haven't returned for any other bad reason, we'll just say we're good. So we'll return true. So this is finite numerical array function will take anything, and it'll only return true if it's a list of numbers. So we can come into here and just say, now we can't return this, so maybe we'll just do something as simple as, actually we'll leave it like this. We'll let it throw. But it'll check to make sure that everything here is in fact an array. All right. Okay, just to recap, we've set up our index.js inside VSCode. we've established our calculator object. We've said our main function is going to be calling this doStatistics call, where we're going to pass in an array of values. We've put properties on this calculator that represent statistics that we're going to fill in. And at this point, we've got it working enough so that it'll at least do a simple test to make sure the data coming in is the right type. And we're outputting the calculator results using a console log to string method, where the to string method is using our formatted strings with this nice backtick operator usage, which lets us inline put our parameters in line to a text output. Okay, so let's go back to our class and see that maybe the first thing we need to figure out is the average. And we could put the function definition in right here, but just for education's sake, we're just going to continue to make some of these helper functions. So we already have this one that's is finite numerical array, and we can use the editor here to collapse that up a bit so it doesn't take up as much room in our editor. And we'll create another one here. Call let's just call it get average, and that is going to be a function. And the function again will take an array of numbers, and we're going to return the average value. So we can create a local variable here called average, and we're going to return average, and we just need to do the calculations. One of the things we'll do is we need to know how many items there are. So we're going to have a count, and we're going to have a sum, and we're going to use the iterators again. And we can do again array of numbers for each. And if you recall again, we're going to have an element that comes in. And we're going to use the arrow operator to do some work. And what's the work we're going to do? Well, we're going to take our count and add 1 to it. We could, of course, just call array a count to start with, but again, just for learning's sake, we're going to do it this way. And we're going to add the element value to the sum. And then just so we can see it, we'll say average equals sum divided by count. Of course, this is why I want to make sure that we don't operate on an empty array, because count will be 0, and we'll return average. So now we've made that function call, we can connect it, we can call it in part of our doStatistics method. So our doStatistics method is here. So we'll just say calculator dot, this dot average. Let's get average array of numbers. And we'll go down to our toString method, make sure that we're outputting the average. So we'll put it here. And we'll introduce a new test. So in this case, we'll introduce tests that we don't expect to fail. So let's do a calculator.doStatistics, and we're going to pass an array in of 1, 2, 3. And we want that to show up in the string, so we're going to make sure that the average is a string, so we should be pretty good to go there. We look at problems. Problems calling out 2 things, so this is nice. This is what we call static inspection. So it's saying there's a problem here. Okay, we're missing a parentheses. And we're missing a parentheses here. All right, so no problems detected. We should be good to go. Let's try running it. Oh, are we all autosave? Yes, we're in autosave. Run. Get rid of that breakpoint. Oh, we did have another error. Line 50. So this must have returned false. So let's go see what's going on there. Run it again. So object to test is not equal to null. Object is an array. Length is fine, right? Length is 3. And then it must not like this. Oh. Turn true. Oh, haha. Just bad logic. Not finite number array. All right. So chalk that up to bad logic. We'll run it again. Get rid of our tests. There we go. Min 0, average 2. All right. Now, one of the things we could have done in any of these calls is we could have just updated a count. So we didn't have to calculate it. So we could have just taken the sum and return .count. That we could fill in this value here. So let's go ahead and do that. And we'll probably do it in this line. Array has we're going to fill in count first. So we're going to say this dot count equals array of numbers dot length. And then we calculate the average. We shouldn't have to do the count. So we'll get rid of the count. And we'll just divide by this dot count. Array has 3 members. Oh, and the average is not a number. So we didn't, it's because we didn't update the count. Right, so we're using not a member function that has access to the object's value. So just to explain what that error was. We said the calculator object, in this case, this owning object is this count. We set it properly to the array length of 3. And then we went to compute average. We called this method, which has no knowledge of the calculator. And we called it, in other words, this is just basically a global function. We called it with an array. So inside our get average function, there was no notion of this dot count. So we probably want to put that back in for now. Let's go ahead and stop execution. All right. right, that looks better. Okay. Let's clear a screen. And just keep expanding out our properties. Now, what is another thing we might want to learn about? Maybe it's time to talk about the date. Maybe we want to know the date when those calculations were done. So inside our calculations here, let's just go ahead and set it at the top. This dot date equals, now we're going to use the global class object, rather, new date, and that will create a data object for us, and we'll be able to use that in our output string. So if we go down here to the bottom, to our toString method, date of calc equals $this date. Now here's all the methods we get off. Well, this isn't all the methods. That's just a helper. So we need to do toLocale string, and give that a shot. There we go. Date of calc 325-220, and gave us the time. There are a lot of ways to convert this string. You can go to W3 Schools to see all the different ways to convert that date object to a string. If you just want the date or the time or different locales or whatever, you can, different time zones, you can get that displayed for you. I'm not going to go any further into that for the date one. But let's go look at something else we can calculate. In this case, we're going to exercise a little bit of the math capability. So let's put in a method after average. One of the things we often want to know is standard deviation. Now, if you recall, in standard deviation, it's the square root of the sum of the squares, where the squares represent the distance between the value you measured and the average. So we can expedite this if we don't have to calculate the average. If we've already got it in determined, we're going to pass that in as a second parameter. So what that'll mean is that we can, again, just do our for each loop and just paste that in because we're kind of used to that by now. And I'm not quite sure. Let's see, there we go. Brace. I'll put a carriage return here. And so we'll put our work inside this for each loop. So in this case, we're going to want to have a value that's represents a difference between our average and our current value, and we're going to square that. So we'll let the diff equal, in this case we're going to use the global math object, which has all these different methods and properties to it. The one we're going to use is the math.power option. We'll pass in the average minus the element, and we'll set that to the power of 2. So that'll be our diff. And then we're going to just add the sum of squares. So sum of squares plus equals the diff. All right. Now, when we need to return the square root of that. So we're going to return math.square root in this case. And it'll be the sum of squares divided by the the length, right, which would be array of numbers dot length. And that should give us our standard deviation. So now in our do calculations, we're going to do this dot I have not added a standard deviation yet. And we'll put in the array of numbers. In this case, we have access to the average, so we can pass the average in. All right, and we want to make sure that we can display it, standard deviation. Okay, that we're used to seeing. I think what I'm going to do is comment out our exceptions. So I'm going to use the editor trick, which if you want to comment out all this code, which is our initial test code to make sure we were capturing our statistics, I'm just going to hit a control / the one underneath the question mark, and I'll comment that out, and we'll run it. It should run a little cleaner. Oh, what's the problem here? So something is not identified. Get standard deviation array of numbers is not defined. And it's index line 35. So we go to line 35. So probably just clear it here. Array of numbers, array of numbers, array of numbers. That looks better. So I obviously used it without the S at one point, so it's coming up in the IntelliSense without the S first. There we go. So we've got our min, average, and standard deviation. Okay, so we've done a little math work. We've done our for each group. Why don't we do something that uses maps and sets? So a histogram might be one of those sort of things. We're trying to figure out how many of something there are. Okay, so let's do the histogram next. So a histogram is going to return an object, and we want this object to let you find out the frequency of each item in it based on the value. So for example, if we had an array of 1, 1, 1, and 3, if we looked up our histogram for 1, we would get a count of 3, and if we looked up 3, we get a count of 1. So we're going to be using a one of the internal classes or objects rather, a map. And let's go take a look. Let's put a new function in here. And this is just going to be a generic function. And we'll call this one histogram will return the count of each item in an array. So that'd be a function. Again, we'll just take our array of numbers, this time making sure to pick the plural. And the object that we're going to be returning let's let our return map equal a new map. And we will return the note return map. So in the middle, what we're going to do is we're going to be populating this, right? So we're going to go through our usual routine where we're going to do an iterator. So we're getting good at doing that one, right? So it'll be array of numbers for each element. And what are we going to do with each one? Well, the first thing we need to do is see if we've already got one. So it turns out you can say the value that's already stored in the map would be done by looking at the return map and getting that element. So if it's found, it'll return it. If it's not found, it'll be undefined. So then we just say if value is not undefined, so then we found it, right? So then we'll just say return map. We'll set the new value equal to the element for that element. So this first argument here is the key. So the key is the element value again. So we can key off of the number. So the key's going to be like 1. And the value now will be the count, which will be the value we got back when we looked for it originally. And then we're going to add 1. But if it was undefined, we're just going to put an entry in since there's no existing entry. And we'll just set it to 1. All right. So that should do it. We look in problems, don't see anything there. We'll use that getHistogram function inside our do statistics. So we figure out standard deviation. Now let's just set this dot histogram equal to getHistogram array of numbers. Now, how would we want to display that? We could just do a for loop. So inside our display, we'll do this before our last line. So why don't we'll set this, we'll say that our output string is done here. This is kind of our header. And then we're going to add to it. So we're going to say for now this is how you go through, use an iterator for going through the entries in the histogram. So you create this array holder of key value, because that's what we're going to get back when we go through our histogram, and it has entries in it. So when we get the entries on our histogram, each entry will be a key value pair or in an array. And then this will get those key value pairs throughout all of our entries in the histogram. So what are we going to do with that? Well, we're just going to add to our output string. So our output string will plus equal, and then we'll get another string where we put a carriage return, which is a \n and a \t for tab, and then we'll store our key, and we'll say it occurs value times. Now we led with a carriage return tab here, so that no matter what we're doing above it, we'll always start out with a new line before we write this stuff out. And we're still returning our output strings, so our method should still work here. And I think now to make the statistics a bit more interesting, maybe we should do a 1, 1, 1, 1, 1, 3, 3.5, whoop, 3.3, 3.5. Let's see what it does there. Debug. Run. Okay, so date of our calculation had 7 members, minimum of 0. Obviously, we haven't filled out our minimum function yet. We've only filled out our average. 1 occurred 4 times, 2 occurred 1 time, 3.3 occurred once, and 3.5 once. All right. So I've showed you pretty much how to set up this framework. I think what we'll probably do for at-home work is see if you can finish up both modifying the string to account for the things we haven't done. So we haven't done min, max. We are outputting the count. We aren't outputting the array, although that's kind of an easy one to do because you can just take an array to string and it'll show you the array contents. We've done the unique items in the histogram. So I think we're pretty much flushed out. So I'll leave it at that, and you can expand the text here for the min, max, and add the functions up here to see how it works for you. All right, so that'll conclude the lecture for today. Thanks.